This video follows on from the Introduction to Calculus video. If you have not yet watched that video, you may want to consider doing so first. Last video, we considered a car moving, and we saw that its speed at an instant is given by dx over dt, where dx means a tiny change in position and dt is a tiny change in time. So speed tells us how two things change together. It tells us how position changes as time changes, and that's what we call a rate of change. Rates of change are all around us. Anytime we compare two values and see how they change together, we are looking at a rate of change. How much fuel does my car consume to drive 100 kilometres? That's measuring a change in fuel against a change in position. How long until my beer is cold? That's measuring a change in temperature against a change in time. You get the idea. Going back to the car problem, let's look at a graph of it. We'll put the car's position up the vertical axis and the time along the horizontal axis. We see that as we move across the graph, the time goes by and the position increases. If the car goes faster, the position changes more as time passes, so the line is steeper. If the car slows down, the line is less steep. If the car stops, then the position doesn't change as time changes, so the line is horizontal. So the rate of change of the car's position versus time, also known as the car's speed, is related to the gradient. Remember back in high school when we said that gradient is rise over run? Okay, so here the rise over any bit of the line is a change in position, and the run is the change in time. So rise over run is change in position over change in time. But from before, change in position is dx and change in time is dt. So gradient is the rate of change. They are the same thing. In this example, the rate of change is speed. Let's say a car is going at 60 kilometres per hour. Then the position of the car is given by x equals 60t, where t is the time in hours. So at 1 hour, it's 60 kilometres away. At 2 hours, it's 120 kilometres away. Its speed is 60, so dx over dt equals 60. The process of going from an equation for position x to an equation for speed, dx over dt, is called differentiation. So to find the rate of change, which is the gradient, we need to differentiate. Differentiation is finding the rate of change between two values, and the rate of change is represented graphically by the gradient. In this example, it might not seem very important to differentiate. After all, we know the speed, it's 60 kilometres per hour, but what happens if the car is accelerating? In this case, the speed, the gradient, is constantly changing. Let's think about calculating the gradient here. If we pick any 2 points in time, we can find the average speed over this time, but that won't be the correct speed at either time. In this case, our old formula of rise over run will fail. In order to find the gradient at a point, we need to find the gradient of the tangent at that point. Mathematically, this is what differentiation is. We will look at this situation in the next video.